There's a number that's been spreading through men's health podcasts, longevity newsletters, and supplement marketing for the past few years. It's not your cholesterol, it's not your testosterone, it's not your resting heart rate. It's called your biological age. And the pitch sounds like this. Forget how old you are on paper. What matters is how old your body actually is at the cellular level. And here's the part that really sells. You can change it. That's a compelling idea, compelling enough that a lot of men over 40 have spent real money trying to measure it, lower it, and track whether their habits are working. Today, we're going to do something the industry around this topic tends to avoid. We're going to slow down and ask a simple question. What does biological age actually measure? What changes it and what doesn't? And what's mostly very well-designed marketing? This is education, not medical advice. Always work with your doctor before making decisions about your health, testing, or any interventions. Let's start with the concept itself, because it's real, even if the claims around it often aren't. Biological age is a genuine scientific idea. It refers to the state of your body's cells, tissues, and physiological systems relative to how long you've been alive. Two men who are both 55 years old can have meaningfully different cellular and physiological profiles. One may have accumulated more damage, more inflammation, more metabolic dysfunction. The other may not. That difference is real, it's measurable in research settings, and it matters for health outcomes. The most sophisticated tools researchers use to measure this are called epigenetic clocks. Here's what they're doing. Throughout your life, small chemical tags, methyl groups, attach to your DNA in predictable patterns. These patterns change with age. Epigenetic clocks are built by analyzing DNA methylation at specific regions across the genome, using machine learning to identify which sites change most consistently with age, and then creating a mathematical model that weights how each site contributes to an age estimate. The first generation of these tools, built by researchers like Steve Horvath in 2013, was genuinely impressive. They could estimate chronological age from tissue samples with remarkable accuracy. But accuracy in estimating how old you are is different from telling you something useful about your health trajectory. A recent commentary in NPJ Aging, provocatively titled, "Do We Actually Need Aging Clocks?" argued that the defining principles of biological age remain conceptually unresolved. That's a researcher talking, not a marketing department. And that tension between what the science shows and what gets sold is exactly what this video is about. A synthesis of 13 studies in a November 2025 systematic review found that individuals with accelerated biological aging, as measured by DNA epigenetic clocks, were consistently more likely to have a stroke. That's the kind of finding that makes biological age measurement genuinely interesting to researchers. But there's a gap between this metric correlates with stroke risk in large population studies and buy this test, follow this protocol, and watch your biological age drop. That gap is where most of the industry lives. When you hear that someone has reversed their biological age, what do you picture? A number on a test going down? A set of biomarkers improving? A longer, healthier life? Those are three very different things, and most of what gets sold conflates all three of them. There are now more than a dozen biological age clocks in active use in research settings: PhenoAge, GrimAge, Dunedin Pace, BioAge. Each one was trained using different data sets, different tissues, different outcome variables, and different mathematical approaches. And when you measure the same person with different clocks, you often get meaningfully different numbers. That's not a small technical footnote. That's a fundamental problem for anyone selling a biological age test as if it were giving you a precise, objective readout of your cellular health. Here's why the disagreement happens. Each clock was trained to predict slightly different things. Horvath's original clock was trained to predict chronological age, how closely the methylation pattern matches what you'd expect given someone's birth year. PhenoAge was trained to predict mortality risk. GrimAge was trained to predict time to death.
Dunedin pace was trained to predict the pace of aging, how fast you're aging relative to your own baseline. These are related but distinct questions, and the fact that researchers optimized each clock for a different outcome means they're measuring overlapping but non-identical aspects of biological aging. A 2025 analysis found that different epigenetic clocks showed weak to moderate correlations with each other when applied to the same individuals, meaning two clocks measuring biological age in the same person could produce estimates that diverged by more than a decade.
So, when a consumer test reports your biological age as 43 when you're actually 51, the meaningful question isn't, is this good? It's, which clock, trained on what data, measuring what outcome, and how does that translate to anything actionable for me? Most consumer products don't answer that question. They just show you a number. Here's the myth worth examining directly. The most common framing in the biological age space is your biological age is a single, coherent number that reflects your overall cellular health. Lower is better. You can track changes over time as you adopt new habits. And the goal is to widen the gap between your chronological age and your biological age. That framing is clean, marketable, and mostly wrong. Biological aging isn't a single process. It's a collection of overlapping, interacting processes: epigenetic drift, telomere shortening, mitochondrial dysfunction, cellular senescence, chronic inflammation, metabolic dysregulation that don't move in lockstep. You can improve one dimension while another stagnates. You can have an epigenetic clock that looks younger while your metabolic profile suggests the opposite. There is no single number that captures it all, which means any test claiming to give you that single number is, at best, giving you one angle on a multidimensional picture. If you had a test that told you your biological age was 3 years younger than your chronological age, what would you actually do with that information? Would it change your behavior? And if it wouldn't, what does that tell you about the value of having the test? None of this means the underlying science is fraudulent. It means the science is genuinely complex, and the products built on top of it are often much simpler than the science supports. There are researchers doing serious, rigorous work on biological age measurement. The Horvath Lab, the work coming out of the Buck Institute for Research on Aging, the ongoing development of clocks trained specifically on longitudinal health outcomes rather than chronological age. All of this is advancing in ways that may eventually produce clinically useful tools. But may eventually is doing a lot of work in that sentence. The gap between a research tool that predicts population-level mortality risk and a consumer product that tells you whether your current routine is working, that gap has not been closed. What has been established, not through epigenetic clocks, but through decades of large population studies, is a much simpler and more durable set of findings about what actually predicts healthy aging in men over 40. And that's where the evidence gets genuinely useful. Let's talk about what the evidence actually supports. Not clocks, not supplements, not cold plunge protocols that went viral in January. The markers that have the longest, most consistent track record of predicting how well men age, and that you can actually move with habits that are already proven. The first is grip strength. This is one of the most replicated findings in aging research. Grip strength, measured with a simple handheld dynamometer, is one of the strongest predictors of all-cause mortality in middle-aged and older adults. Not because hand strength matters in isolation, because grip strength is a proxy for overall musculoskeletal integrity, neuromuscular function, and systemic resilience. Men who maintain grip strength into their 60s and 70s live longer, recover faster from illness, fall less, and maintain functional independence further into old age. The relationship is dose-dependent,
meaning more is better, and decline is meaningful even before it becomes obvious. And here's the part that connects directly to the biological age conversation. Grip strength responds to resistance training, not to supplements, not to epigenetic reprogramming protocols, to progressive resistance training applied consistently over time. The mechanism is real, the evidence is deep, and you don't need a test to track it. You need a hand grip dynamometer that costs $30. The second marker is VO2 max. VO2 max, your body's maximum capacity to use oxygen during exercise, is arguably the single most powerful predictor of longevity in the research literature for men over 40. More powerful than most biomarkers, more powerful than most epigenetic clocks in head-to-head comparisons. A landmark analysis published in JAMA Network Open found that men with low cardiorespiratory fitness had a dramatically elevated risk of all-cause mortality compared to men with even moderate fitness, a risk comparable to or exceeding that of smoking, hypertension, or type 2 diabetes. Low to moderate VO2 max is not a number on an epigenetic test. It's a measurable, improvable physical capacity, and it responds to one primary intervention: sustained aerobic exercise with progressive intensity over time. You can estimate VO2 max without a lab. The Rockport walk test, the Cooper run test, and most modern fitness wearables provide clinically useful estimates for tracking direction and rate of change over time. Not perfect, useful. The third marker is fasting insulin and insulin sensitivity. This one doesn't get the attention it deserves in most men's health content. Fasting glucose, the number most men see on their annual labs, captures overt diabetes and prediabetes. But fasting insulin captures something earlier: the degree to which your pancreas is having to work harder to maintain normal blood sugar. Insulin resistance is one of the most consistent drivers of accelerated biological aging across multiple frameworks: epigenetic, metabolic, cardiovascular, and cognitive. A man with normal fasting glucose but elevated insulin is not at the same metabolic risk as a man with both normal. But the standard lipid panel and the standard glucose panel won't show you that difference. Asking your doctor to include fasting insulin alongside your standard metabolic panel is a low-cost, high-information request. It requires one additional blood draw, it has no consumer product attached to it, and it gives you a signal about metabolic trajectory that most annual physicals currently miss. Grip strength, VO2 max, fasting insulin. These three markers are measurable, improvable, and have decades of outcome data behind them. How many of them do you actually know your current numbers for? And if the answer is none, what does it tell you that you know your biological age from a consumer test, but not these? There's also a fourth worth naming: waist circumference. Not BMI, waist circumference. Specifically, the ratio of your waist measurement to your height. Research consistently shows this ratio is more predictive of metabolic and cardiovascular risk than BMI, which conflates muscle mass with fat mass and systematically misclassifies men who are over-fat but not overweight by the scale. A waist-to-height ratio above 0.5, meaning your waist is more than half your height, is associated with significantly elevated cardiometabolic risk across multiple large population studies. It's a 3-second measurement that requires a tape measure and basic arithmetic. No app, no subscription, no biological age clock. Let's also name what doesn't have the evidence the marketing implies. Telomere length testing has been heavily marketed as a measure of cellular aging. The science is real. Telomeres do shorten with age, and shorter telomeres are associated with higher risk disease in population studies. But the association is weaker than most marketing implies. Individual variability is enormous, and the clinical utility of a single telomere length measurement for guiding behavior in an otherwise healthy adult has not been established. Most supplement protocols claiming to improve biological age scores have not been validated in rigorous, peer-reviewed, randomized controlled trials with biological age as the primary endpoint. The studies that exist tend to be small, short, and conducted by researchers with financial interests in the products being tested. NMN, Resveratrol, Rapamycin at unapproved doses, senolytics from consumer brands. These are areas of genuine scientific interest. They are not proven anti-aging interventions for healthy adults. The gap between interesting in a mouse model and worth taking based on current human evidence is significant, and the industry consistently collapses it. So let's bring this down to what's actually worth your time and attention. The biological age conversation isn't going away. The testing market is growing. The podcasts will keep featuring longevity researchers with compelling numbers, and some of that science will eventually produce tools that are genuinely useful in clinical practice. But right now, in March 2026, the honest position is this: the most powerful things you can do for your biological trajectory as a man over 40 are not new, not expensive, and not measurable by a consumer epigenetic clock. They are measurable, just not that way. Here's the practical framework. Track what has decades of outcome data behind it. Grip strength. Test it. A hand grip dynamometer costs between $25 and $50. Test both hands, 3 attempts each, take the average. Reference values by age and sex are publicly available. Track it every 3 to 6 months. If it's declining, that's a signal worth addressing. Not panicking about, but addressing. VO2 max. Estimate it. If you have a fitness wearable, a Garmin, Apple Watch, or Polar, it's already calculating an estimate from your heart rate during exercise. If you don't, a 12-minute Cooper run or a 20-minute Rockport walk gives you a usable number. Your target as a man over 40 is to stay above the threshold for good cardiorespiratory fitness for your age group. Tables are publicly available from the American College of Sports Medicine. Fasting insulin. Ask for it. At your next annual or metabolic panel, ask your doctor to include fasting insulin alongside your standard fasting glucose. If they ask why, you can explain that you're interested in early metabolic signaling beyond what fasting glucose captures. A good clinician will understand the request. Some will already be ordering it routinely. Waist to height ratio.
Measure it. Right now, if you want. Measure your waist at the narrowest point between your ribs and your hip bone, typically just above the navel. Divide by your height in the same unit. If the result is above 0.5, that's a flag worth addressing. Not a diagnosis, but a signal. These 4 markers, grip strength, VO2 max, fasting insulin, waist to height ratio, give you a more actionable, more evidence-based picture of your biological trajectory than any consumer epigenetic clock currently on the market. They're cheap to measure. They respond to interventions that are already proven, and they don't require a subscription. What actually moves these markers is not a secret and not a supplement stack. Progressive resistance training moves grip strength and muscle quality. 2 to 3 sessions per week, compound movements, increasing load over time. That's the evidence. Zone 2 aerobic training, sustained moderate intensity cardio where you can hold a conversation but feel genuinely challenged, is the primary driver of VO2 max improvement in adults over 40. 3 to 5 hours per week is what the research supports for meaningful adaptation. Dietary carbohydrate quality and quantity, combined with resistance training and sleep, is the primary driver of insulin sensitivity improvement. Not a specific diet brand, not intermittent fasting as a magic bullet. The combination of reduced refined carbohydrate load, adequate protein, and resistance training applied consistently. Sleep. 7 to 9 hours of adequate sleep is one of the most consistent drivers of metabolic health, inflammatory markers, cortisol regulation, and testosterone maintenance in men over 40. It's also one of the most under-addressed variables in men's health content, possibly because it doesn't have a product attached to it. If you replaced the money and attention you're currently spending on biological age testing or anti-aging supplements with consistent resistance training, zone 2 cardio, and adequate sleep, what would your trajectory look like in 5 years? Not your clock score, your actual physical capacity, metabolic health, and functional independence. A few things worth being clear about before we close. None of this is an argument that epigenetic research is worthless. It isn't. The science is advancing, and tools that are genuinely clinically useful, validated in prospective trials, agreed upon across multiple research groups, and interpretable in terms of actual behavior change may emerge in the next 5 to 10 years. Following that research is worthwhile. What this video argues is that the current consumer market has outrun the current science. The tests available today are measuring real biological phenomena and then packaging them in a way that implies far more clinical precision and actionability than the underlying data supports. That packaging is expensive, and for most men over 40, the return on that investment is lower than the return on the habits we've just described. Skepticism about marketing is not the same as skepticism about science. The underlying science of biological aging is fascinating, genuinely important, and worth paying attention to. The products built on top of it right now deserve a harder look. If you want to track your aging trajectory in a way that's grounded in evidence, grip strength, VO2 max, fasting insulin, waist-to-height ratio. If you want to improve it, resistance training, zone 2 cardio, sleep, dietary carbohydrate quality. These are not exciting answers. They are the answers the evidence keeps returning to across decades of research in population after population. The goal was never a better number on a test. The goal is the decades, and the path to them is less novel than the industry would like you to believe. As always, everything in this video is for educational purposes only. It is not medical advice. Speak with your doctor before making changes to your exercise routine, testing, or any aspect of your health care. If you want health conversations that cut through the noise and stay grounded in what the science actually shows, subscribe to Golden Thriver. We cover the topics that matter to men over 40 without the hype and without the shortcuts. And if you've already had this conversation, if you've spent money on a biological age test and want to share what you found useful or not, drop it in the comments. That's exactly the kind of real-world experience worth sharing. We'll see you in the next one.